Good evening, everybody. So you'll see here I'm trying a different color background. Some people like the white, some people like the black. So I thought maybe let's try gray, see how, or excuse me, green, see how this works. So again, let me know if you like this one better than the other ones. Um, and anyways, we'll go from there. All right, so we're going to start talking about polynomials. We've already talked a little bit about this earlier in the year when we were doing those packets from the Common Core stuff. So a little bit of this review, but we'll go ahead and act as if it's new. So first thing we do is talk about monomials and define monomials. So a monomial is a number, a variable, or the product of the two, with a whole number exponent. That is an exponent that is either 0 or positive, so no negative exponents. One thing you kind of want to remember here is that monomials are no negative exponents. Okay, again, make sure you're writing lots of fifth color on this. Okay, so monomials, we usually think of it as just one number. Think of the word mono meaning one in other languages. So it's only one term is another way we might say it. So it's just one term. Okay, now let's talk about the degrees of monomials. So to find the degree of a monomial, what we do is we add all the exponents. Whoa, that's a terrible all. Hello. Even bad by my standards. All exponents on the variables. Okay, so I'll do a couple examples here. That's probably the easiest way. So if we have the example 3x squared, that has a degree of 2 because the exponent is 2. So that's a second degree monomial. Take a look at another example here. 4xy cubed. That's going to be a fourth degree because we have x to the first and x to the third, so that equals x to the fourth, or not x to the fourth, but or y to the third, that equals the fourth degree. And I'll do one more example here, and that is 9. And since we don't have a variable, that means the variable must be 0, so the degree of that monomial is also 0. Okay, so that's monomials. Now polynomials are monomials added or subtracted together. Okay, and we have different types of monomials. Some of them are called binomials, meaning two terms. And we also have trinomials, meaning three terms. Okay, so bi meaning two and tri meaning three, just like bicycle and tricycle, same exact thing. Okay, now for degrees of polynomials, what we do is we look at the largest monomial, the largest degree monomial, and that's the degree of the polynomial. So if I have this 3x plus y to the fourth plus 2xz. Okay, so this one is a first degree, this one is a fourth degree, and that one is a second degree. So since this is the biggest one right here, this is a fourth degree polynomial. Okay, so we just look at them and write it as the biggest degree polynomial, or we name it by the biggest degree polynomial. And that's how you do polynomials. It's the biggest one. So monomials, you add them together. Polynomials, you're looking for the biggest degree monomial. Okay, let's take a look at the next slide. Okay, so here we have some adding and subtracting of polynomials. So you see I have 2 cubed minus 5x. Oops, I forgot my square there. Excuse me. 5x squared plus x plus 2x squared plus x minus 1. Okay, whenever we do adding and or subtracting of polynomials, what I want to make sure we do is that we add the same degree monomial. So I'm looking for the same exact exponents. So same variable, same exponents. So what I look at here is I see I have an x cubed, and over here I have an x cubed. So those two I can add together. So here I have 2x cubes. I have 2x cubes here and 1x cubed there. Therefore I have a total of 3x cubes. Then I go to my next one and I see that I have some x squareds here. Notice that I don't care about the coefficient in front. I'm only looking at the variable. That tells me if I have the same base or not. So this one tells me that I have 5x squareds, and this one tells me I have 2x squareds, which means I have a total of, important thing though, almost messed up, a negative 5x squared. That negative has to go with it. So when we do this, I want you guys to circle the negative, and then this one, of course, circle like that. And now that leaves me with negative 3x squareds. And then I go on to my next one, and I see that I have an x here, and I have nothing on this one. There are no x's over here. Therefore, I'm just going to circle that and leave it, and I get plus x. And then, of course, my last one here, I see that I have nothing to go with this, so I just added it at the end. So minus 1 at the end, not 7, minus 1 there. And that's my answer. Okay, so my answer then is this right here. What the heck? This right here is my final answer. All right, now I'll do the same thing down here at the bottom one. I'll do a little bit faster this time. So I have, I'm just looking for the same size monomials, the same exact bases here. So I have x squared here, or excuse me, x cubed here, x cubed there. So I'm going to circle that, and I'm going to circle including the sign in front, so I get a total of 7x cubes. And then I see that I have, well then you know what I notice right here is, that's right, I forgot I did this on purpose actually. These two are the same. So I can go ahead and CLT those right off the bat. I don't have to do anything with the other one because I get 4x minus 2x, which gives me 2x right there. And then I have this, and over here I have nothing. Therefore, I'm just going to have plus 2x. And then I look and I see that I have a x to the fourth right here. So I can circle that one, and no x to the fourth, or x squared, 4x squared, excuse me, and like that. And then my last thing that I see that I have is I have 18 here, but nothing there. So then I can circle that one, and circle that one, and I end up with 12. Now, this is fine, this is correct, but it's not the best way to write it. The best way to write it would be to write it so that we have the biggest exponent first and the smallest exponent last. So it'd be best if we had 7x cubed plus 4x squared plus 2x plus 12 would be the best way that you could write this. So we want to get in the habit of writing the biggest exponent first if we can. Okay, let's take a look at the next slide. Kind of the same thing here. We have subtracting polynomials. The difference here is that we want to think about what this symbol is telling me. I have a negative outside of a parenthesis, so we can think of that as a lot of different ways. We can think of this as the opposite of. We can think of it as keep, change, change. So you would change everything over here. That's actually what I'm going to do. I'm going to use keep, change, change. You also can think of it as this is the opposite of everything on the inside, but you do want to rewrite this. You certainly don't want to try and subtract it without rewriting it. Now, it's okay if you want to rewrite it like this. If you wanted to use keep, change, change, I'm cool with that. So we're going to keep the first term, which is the first parentheses. I'm going to change that to addition, and then I have to change everything on the inside of my parentheses. And please make sure you do that in a different color so that I can see that you've done it in a different color. Now I just have adding polynomials just like we did before. So once I do keep, change, change, I just add my polynomials just like before. So I see that I have n squareds here and n squareds there. That gives me a total of 6n squared. And then I have negative 2n right there, so that's minus 2n. And then lastly I have plus 5 and plus 4, which gives me plus 9. Notice that I did it from largest to smallest. Okay, so that's that one. Now take a look at this one, same type thing. I'm going to use keep, change, change. And this says the opposite of my second one, so I'm going to change that to addition, change that to all of the opposite signs on the inside of my parentheses. So now when I go to find my like terms, I see I have 5x cubed there and negative 4x cubed there, which gives me x cubed. I have 2xy here, and I have nothing here. This looks like it might be the same, but it's not because of that x squared. Therefore, I don't have anything else. So then I'm just going to leave it 2xy. And then I go to this one next, and I see here that I don't have anything that matches that one either. So that's going to be minus x squared y. And then I'm going to go back to my variable, my next variable that is, which is this one here. So that's plus y. And then the last thing that I always do is my constant. And so my constant here is plus 8. So then I say plus 8. Okay, so then this is my final answer right here. There's nothing else to be combined together. These cannot be combined because they have different exponents. So even though they're the same letters, that square changes it from this one. Okay, and the last slide that I have here is, I would like you to take a look at these two problems, problem A and problem B, and describe for me the major difference between these two problems and how does it affect the outcome. So take a look at the two problems and tell me what the major difference is between them and how will that affect the outcome. Okay, I'll see you guys tomorrow. Hopefully anyway. Sorry about being absent again today.